Hi.
Hey, Sean, are you there?
Yeah.
All right. How's your day going for you?
Pretty good.
Okay. Tell me about the class. How's that coming along?
Um, Decent, I'd say.
Indecent?
Decent.
Decent. Okay. I know you're having some kind of struggles with it last time. Were you able to solidify those struggles and do a little better, or what's going on with those?
Kinda. I've been like pretty busy. I have like a lot of tests this week, so haven't had much time to like study.
Oh no. What's going on this week?
Yeah, I have like 5 tests tomorrow for like all my classes and like
Five
more
tests?
on Friday. So yeah.
Oh my goodness. How you handling the stress level?
Um, I don't know. I'm just like splitting up my time at this point. So yeah.
Okay. Okay. Um, Tell me how the class is going for the most part. Are you feeling overwhelmed, or are you feel like you're just treading water? How do you feel like it's going?
Um, Decent, I'd say. I feel like I really need like a lot of practice for stuff and like I'm struggling on some of the problems. But like I don't really have much in like specific.
Okay. Well, I'll tell you what, let's jump over to the bit paper. You said you had certain problems you're struggling with.
Yeah, but I don't have like any like specific problems. It's just like overall.
Okay, tell me what kind of problems you're struggling with.
So like antiderivatives and like indefinite integration and like the net change theorem.
Okay, let me see what I got here. Okay, give me a moment. Okay, are you looking at problems like this?
Um yeah, kind of. Yeah.
Okay, well, let's kind of go through these then. Show me how you're going to start working through these if this is on your exam. Okay, explain to me what you're doing right there.
I was finding like the area under the curve for this.
Okay, what actually is that?
Um a quarter of a circle.
Okay, so you got the piece down here, but you also have this box down below.
Yeah.
Okay.
Yeah, just 5 plus 4.
Okay, I think you're probably okay with that then. Uh, yeah, you're just gonna find your geometric shapes and do whatever you gotta do to crank it out. Just make sure you have the area of the circle like you're doing. That's pi down below. You're gonna get 2, and then you're at 2. Okay, let's jump to number 2. What if they gave you this problem instead? How would you work number 1 or A? Okay, good. That'd be 3 right there. Okay, tell me what you did right there.
So I found like the width of each of the triangles,
Okay, good. So you got some triangles.
and then I found the height at like the points, which would be the same because like they're the same distance away, and it's like absolute value.
Yeah, not too bad here in this case. What if it was something like 6 instead of 5 or 8?
Then I would have just did it the other way around and kind of just made this at 6 and found the value at 6.
Yeah, so you have your base times your height. So you'd have that.
Yeah.
Okay, now that one's usually not the real problem one students have. It's really B and C's where they start kind of tripping up a little bit. And let's just go ahead and say it's positive there. Don't worry about that. Negative. What would you do for that problem? Now, what is that curve?
Um, what you mean?
Okay, you see how you're a little bit hesitant right there and trying to graph it
Yeah.
out?
Yeah.
My guess is you're trying to figure out how to write the square root function.
Yeah.
Okay, that's a real common mistake because when you graph the square root function, maybe something like this, what's your power on x?
Squared.
Over
2.
here is squared. When you graph the square root function, it's first power. So it's completely different. So this is what you need to do. Like you did in the first one, you didn't realize it. You ignore the integration, extrapolate it, and graph your function. Now here it's going to be a little bit of a challenge. So what if you square both sides and then move the x over? Do you see it now? What is that?
Yeah. A circle.
Circle. So when you see that square like that, start thinking of conics. And so going from -3 to 3, and integration talks about the area under the curve. Oops, not that, because it's positive for the radical. We just want the top part. Pi r squared, and then divided by 2. Try C. I say making it a little bit more of a challenge, but do the same thing. Extrapolate and see if you can identify the curve. Okay, so what kind of curve is that one?
Um, a circle.
It's not a circle. Let's graph it out. What happens if x equals 0? What's your y value?
1,
Or,
-1.
and what happens if y is 0? What's your x value?
1, no, 4, 2,
2. Or,
or -2.
so what is this? Is that a circle?
No,
What's that called?
oval.
Okay, oval or an ellipse.
Yeah.
So if you have a different value down below, like you have right here, it's not going to be a circle. But you still got to figure out what the area is. And we're going from 0 to 2, so since it's a positive radical, we're talking about that region right there. So whatever the area is, I'm going to have to take it and divide into fourths. All right, Eshan, what's the area of an ellipse?
I don't remember.
What's the area of a circle? Okay, tell me what a circle is again. It's an object which has a center, and all the points, what are they called?
Um,
Equal distance. So when I go from here to here, it's the same if I go from here to here. And we typically refer to that distance as the radius. Look at your ellipse. If I go from here to here, is that the same from going from here to here?
no.
So it's like I have two different radii, isn't it?
Yeah.
Now look over here again. If you look at r squared, that's like saying r times r. Over here, if you have your two different radii, maybe it has a radius of a, maybe it has a radius of b. It's like saying two different radii multiply each other, a and b. The equation for an ellipse is something of the form of x squared over a squared, y squared over b squared equals 1. So in this case, you have 1 squared and you have 2 squared. The area of the ellipse, 2 pi times 1. Then take it and divide by 4, pi over 2. Okay, so this is also a real common problem to see. Looking at the formula for an ellipse, just have to remember it's like a circle, just like you have two different radii. So if they give you a problem that says something along the lines of 1 minus 9x squared, don't think about square root graphs, because that's not always going to happen here, because you're squaring the variable. If I say negative a third to a third, be very suspicious. Probably talking about a circle or talking about an ellipse. Take it, pull it, extrapolate it, square it, and then you're going to have to put it into that format. Move the 9x squared to the other side. And here's where it gets a little bit tricky. You're going to have to unsimplify the fraction to make it fit. But if you do this, you'll very quickly identify the A and the B and the C, or the A and the B if you need to. And there it is. So since we know what the formula is now, we know we're talking about principal square root. So we're above the x-axis. I'm going to take half the area. Pi 1 third, 5 or 6. Okay,
Okay.
let me stop there to see if it's making sense to you.
Yeah.
All right, good. I'm gonna throw these problems your way now. See if you can take a moment and integrate these.
Do I have to put like this over here?
Well, what is that doing? What is that?
Um, I'm not sure.
Okay, so tell me what that symbol is. I know what you're doing. You're getting a little confused. If I gave you this, you would say this. This is an evaluation symbol, which you're imply the fundamental term in calculus and plug it in. Do you have any points to plug in here?
No.
No. So what you're going to do is just say plus C, and you're good to go. These are called indefinite integrals because you do not know definitely what the endpoints are. Now, this is a great problem for an exam. Half the students will get it right, and the other half will get it wrong. What's the integration of 0?
Just C.
You got it right. Okay, keep going. See if you can figure the rest of these out. Okay, I forgot something. Go back and check it. Plus C.
Oh,
Yeah, don't forget the plus C. All right, I'll pull this down a little bit more, give you a little more room there. I'm curious now. Let's see how you're going to approach the next one. Okay, tell me what's going through your mind.
not really sure how to do it.
Okay, so when you see this problem, is your anxiety going up a little bit, or are you just feeling stuck?
I'm just like stuck.
Okay. Well, when you're feeling stuck, here's what I want you to do is ask yourself, not that I can't do it, but ask yourself, why can't I do this? So, Eshan, why can't you work this problem? Okay, go ahead and answer. What's causing you from not working this problem?
Um, the x in the
In the
root x
denominator.
in the denominator.
Okay, because you want to use, which property would you like to use for this problem?
Um, quotient rule.
Not quotient rule, because you're integrating. You probably want to use that power rule, like you did in the other problems. Okay, so we can't solve it because there's a square root down below. And I would love to use power rule if I could. But I got a conundrum. So don't look at the integral. What you're going to need to do is take this and manipulate it so that you can. Now, the next thing is, what you want to do is look at, see what kind of function you have. Is it a trig function? Is it a logarithm? Is it an exponential or a rational function? Different functions are going to kind of lead to different ideas when you go about your procedures here. In order to have it as x to a power, I need to have x by itself. This is my goal. So once I identify the problem, I can then formulate a solution. There's a square root down below. Now, listen to my thought process. I can't solve this, there's a square root down below, but I know something about fractions. I can take it and I can break it apart. And as soon as I break it apart, I can utilize properties of exponents and I can recalibrate it. Now I can apply the power rule. So if you integrate both pieces. And this goes back to the previous problem that you did, as well as this one. And don't forget about the plus c at the end. Okay, so in these kind of problems, in which you have a single term down below, this is generally the fastest way to go about this. Look at this one right here. Try that one now. Identify the problem. I can't apply the power rule because there's a x squared down below. So what are you going to do about it? Good. Good. Now, we'll take that negative off there. We don't need that negative there yet. Okay, that's perfect. You're recalibrating it, makes it a little easier for the next step. Go ahead and integrate now.
Hmm.
If you integrate 1 over x, that's a special identity. Make sure you know this.
Oh,
Natural log,
okay.
not parentheses. Absolute value. Move up for the next piece. Good, good. And divide by it. and then tack on your plus c. Perfect. Okay, let me take this problem and make a slight alteration to it. Let's put trig functions up now. Notice how you still have one term down below. Do the same thing.
What?
Yeah, could take it up top. I know you're saying. There it is. Okay, now if you integrate, can you integrate now? The integral cosecant.
So the
Get something like that. Oh, let's think. I think there's actually maybe a negative in front. Don't forget about the plus c. Okay, let me take this problem. I'm going to change it up again. And let me give you this one. Suppose if I gave you that. Okay, so when you look at this problem, what goes through your mind?
um wait, oh, I can't do that.
You sure would like to use the power rule again, wouldn't you?
Yeah,
But why can't you apply the power rule?
because you can't like simplify it enough.
Because you gotta have x in the numerator, not in the denominator. Now, I can't do the same thing here. I can't take this and break it apart like in the previous problems. Now, if it was like this, I could, but I don't have that. So if I could do something like that, though, that would make it pretty easy, wouldn't it?
Yeah,
Okay. Do you see how we're kind of exploring a little bit? We're trying to develop a solution. We're just kind of playing around, trying to get a good idea.
yeah.
Okay, so let me ask you this question. We got a good strategy over here. What's keeping me from using it over here?
That's flipped over.
It's flipped over. What else do you see?
Um,
Here I see a single term down below. How many terms do you have down here?
two.
Got two. So that causes a little bit of a problem there, doesn't it?
Yeah.
Now, here's what I could do. In order to incorporate this idea, what would I need up top? The same thing. I would need an x plus 1. Let's put one up there. But I just can't put one up there. I gotta subtract it off. What's 1 minus 1, by the way?
0.
Did I change anything by doing that?
No.
I just changed the way it looked. Then I'll do the same thing. I'll take this and I'll split it. When I integrate the first piece, I get x. What happens when I integrate this piece right here?
Um, the same thing.
Not the same thing. What was the integral of dx over x plus 1? U sub it. And what's the integral 1 over u?
Ln of u.
You got it. Make sure it does say absolute values. And then drop it back in. Okay, now these kind of problems, you might see them on an exam. Either you get it real fast, or it's going to take you a really long time to go through it. This is the fastest approach. Let me throw you another one. Just kind of curious to see how you're going to approach it. Okay, I'm going to make a slight adjustment to the problem. And first off, let me just say 2x on top. If they threw you this problem, what would you do? How would you solve it? Not that here in this case. The fastest way, the best way to do an integration problem is start off with a u sub. So when you see a rational function, think about taking the whole entire denominator and make that equal to u. Okay, so if you made that u, how would you trade everything else out?
Um, I don't know.
Okay, we gotta get the differential, take the derivative, and derivative for x squared is
2x.
do you see this over here in the problem somewhere?
Yeah.
It's the whole entire numerator, isn't it? So let's take it and drop it in. Now, we'll take the natural log, go back to the original variable, and there it is. Now, this is also a really good test problem because look how much work there is. There's not a lot. And if you didn't know how to work the problem, you'd be spending a long time on here. Okay, so let me take the problem now, make another adjustment. Suppose if you had this one. Could you do a u sub on this problem? It's not really working out too well, is it? Because if you set this equal to u, this is your du. And if you start trying to plug everything in, you can get the whole entire denominator. The dx is going to be du over 2x, but you still have the x squared. In order for it to be a good u sub, you have to be able to convert everything over. Not what you hope to convert over, not what you think you can convert over, but all the x's must be expressed in terms of u. I'm having a hard time with that. So what this is telling me is probably u substitution is not really the ideal way to go here. So let's go back. And you have to ask yourself, why can't I do a u sub? U-sub's the first technique you should really try before you do anything else. It's because of that 1. So let's add 1 and subtract 1 and split up our fraction. This becomes 1. Now you have this. You integrate 1, you get x. Do you remember what this one is?
Um,
Special identity.
I don't know.
This is your arctangent. This comes up all the time, Sean. You gotta know this one. So over your notes, make sure you do have this. And the other one you gotta know is the arc sine. Okay. These will come up. Make sure you do know these two. The other ones, the other inverse trig functions, they don't come up that much. It'd be really worth your while, but these two do. Know this. Okay. Now let's go back up here to the problem set. And whenever I see a monomial with just a 1 term in the denominator, that's usually the idea I'm going to do. I'm going to go ahead and divide it out, split up my fraction. Okay, how would you do this one right here? 1 over x cubed. Right, because you can't apply the power rule because it's not an enumerator.
Yeah.
Good, you got it. Don't forget about the plus c though. Try that last one. Okay, tell me what you're doing there.
Um, kind of splitting it up, I guess.
Okay, so you're doing some trig identities. And sometimes that's what you want to do. Sometimes not. Let's back up. So you could take this and you could calibrate it like this. Now, Eshan, whenever you see a set of parentheses, a good idea is to do a U sub. See, U substitution is the analog of the chain rule back in differentiation. You're looking at function compositions, F composed with G. And the integration rule is called U sub, over here is called chain rule. If I see a set of parentheses, I might want to snag and grab it and make it U. Okay, if that's U, how's your integral transform over?
Um, sine of x over cosine u squared of u squared.
Go ahead and plug it all in. Let's see what you're going to get. Don't forget the integral symbol. How are you going to convert that dx over?
Um, I don't know.
Look at your conversion right here. What's derivative for cosine?
Um, Negative sign.
Solve for dx. Plug it in. What do you get? And don't forget the integral sign. They're going to mark off on you if you do. Where did that 2 come from? I'm a little confused.
I substituted like d of u for 2u.
Well, here's d of x. So when you plug it in, it's du over negative sine of x. Signs go away. And that's really what you got. Okay, so it seems like you're doing okay looking at the basics, these kind of problems. But when we start getting into the U sub, that's really where you're starting to have problems, looks like.
Yeah.
On your exam, is going to do more U substitution or more basic type of problems?
I'm not really sure.
Okay, so let's just keep looking at some U sub problems here. And here's what I want you to do. I don't want you to solve it. I just want you to tell me what the U sub's going to be. What do you want U equal to?
3x minus 1.
Why?
That way we can do like chain rule and
Right. You see a set of parentheses. What do you want to do for part B?
3x minus 1 again.
Good. What about for part C? What about part D? What about part E? Oh, that doesn't work. If you set equal to x, all that's going to do is change the u's and the x. It doesn't help at all. Why do you want to equal the sine of x for?
Because x is being squared.
Good. What about part F?
Yeah.
Okay. Now, let's go back here to part A. Go ahead and do part A for me. Okay, so I'm gonna back up. I'm gonna give you an idea when you're working these problems. I keep seeing you're stalling out a bit. Once you make your substitution choice, What I want you to do next is calculate your differential right away. So if you take that derivative, what do you come up with?
3.
Not just 3.
3 plus c.
No,
Wait,
3 dx. Don't forget that dx. Okay, now after you do this, here's what I want you to do next. Solve for dx. Okay, so once you got your u in place, you got your dx in place, now take everything and plug it in. Okay, tell me why you did that. I'm confused now. So you did a substitution, you plugged in, you went right back to x. You got to make everything in terms of u. Don't forget the integral symbol. They will count off on you. Pull out the 1/3. Can you work the problem now? Okay, they're also going to count off on you if you put the integral symbol after you integrate. Don't do that. So after you integrate, leave it off. And don't forget about the plus c. Now, what were you originally integrating in respects to? Was it x or was it u?
x.
So back substitute now. Okay. Now, I'm going to jump down to here due to time. And I want you to look at h. This is the tricky problem. A lot of times when you're working these problems, yes, Eshan, you usually just take the whole entire denominator, but not always. What you're going to do is take the x to the 4th, and you're going to recalibrate it like that. That's the trick here in this problem. You're finding compositions. It's not always easy to find the compositions. Set u equal to x squared. And then remember our strategy, we're going to immediately just say du. And then we're going to take everything and plug it in. Now, another approach is I don't really have to solve for dx. I can solve for x dx, because what do I have right there? X dx. So that's a little faster approach than always solving for dx. But solving for dx will definitely work out. Here's that special identity that says it's going to keep popping up, and you really got to know it. Arctangent. Arctangent of u, but u is going to be x squared. So we're going to take it, we're going to drop it, we're going to replace it, and there it is. Okay, now another problem that I would expect them to put on your exam is something like I. What would be a good use up here? Good. Okay, so when you get to use up, I want you to get your du right away. There it is, good. Okay, change it all over now. Convert it. Perfect. How are you going to change the x over?
Um,
Go back to your conversion factor right here. Solve for x. See that? Take it and drop it in. Now, what would be your final push here in this problem?
um, power rule?
Distribute.
Not power rule, product rule.
No. You don't really have a product rule, at least not what you think it is. But you are going to distribute. Oh, let's actually make it a little bit faster. Just don't do that. Let's go 3/2, because we know it's going to be 3/2 in the end. So we'll save ourselves a step and convert it into exponential notation at the same time multiplying it. Then I'm going to take my exponents, I'm going to raise it up. So I'm going to have 5/2, flip the fraction in front. 3/2, same thing. Now, we can drop in the u, but we also know it's going to go back to x minus 1 anyways. So let's save ourselves a step and just drop it in. Okay, now, if this was an integration problem or an exam that had a u sub on it, I would guarantee put some of these on here, or at least some things look like it. I definitely put something like B on. It's a real fast problem. You either know it or you don't. I would do a trig problem. There's a lot of things with trigonometry which are very important in calculus, and this is also able to test that concept at the same time. And I would definitely put one of these problems on because it's not a typical run-of-the-mill substitution problems. You actually have to go back and redo it, have to solve for x, trade everything else out. This one I might put on an exam. It's a kind of a challenge problem, but it's there to see where the students are to kind of gauge them. And again, the technique is you take it and you square it. And if you didn't know this, this is going to be a time sink and you're not going to be able to finish the test. At least not finish this problem on the test. Okay, now all these problems again are definitely good contenders to put on an exam. What I would like for you to do later on today is go through all these problems again and see if you can redo them. And let me throw you a few more problems here too, to practice. Okay, so here's your indefinite substitution ones that we just did. And here's your fundamental thermal calculus problems you want to review. Alrighty, Sean.
All right, yeah.
Now, don't forget about jumping over here. You can go back to some of the things that we talked about last time, our previous discussions. Okay, that
Okay,
should
yeah.
help out. All right, well, if you need anything else, let me know. Let me know how the exam goes. Is it tomorrow or is it on Friday?
There's two parts. We have MCQ and short answer tomorrow, and then we have two FRQs on Friday.
Okay. How are you feeling about the FRQs?
I'm not really sure.
Okay. Okay. Um, how about for the multiple choice? You feeling better about them or?
Yeah, I'm feeling better for the multiple choice.
Okay. Well, I also have those videos for you to watch too. You can go through, you can just kind of try to soak it up, some of the information. on use substitution, some integration. So let me know if you need them.
Yeah, thank you.
All right. Well, let me know how things are going. Other than that, I'll see you next time then.
Yeah, thank you. Bye.
Take care.
I hope that today's lesson was a positive and an encouraging learning experience, and that you have a better understanding of how to solve these problems. Be sure to set some time there today and throughout the week to review these concepts, to rework these examples so that you're better prepared for the next lesson. If you need anything, just let me know. You're always welcome to send me an email or to stop by during office hours. Until next time, keep up the good work and have a great day.